Welcome to another physics tutorial. Today, we're solving a problem about a proton being accelerated. Let's get started. The problem says, a proton with a mass of 1.67 times 10 to the power of negative 27 kilograms is being accelerated along a straight line with an acceleration of 3.6 times 10 to the power of 15 meters per second squared. Its initial velocity is 2.4 times 10 to the power of 7 meters per second, and it travels a distance of 250 meters. We need to calculate two things: the final velocity of the proton and the increase in its kinetic energy. Let's summarize the data. The mass of the proton is 1.67 times 10 to the power of negative 27 kilograms. The acceleration is 3.6 times 10 to the power of 15 meters per second squared. The initial velocity is 2.4 times 10 to the power of 7 meters per second. The distance traveled is 250 meters. We are finding the final velocity and the increase in kinetic energy. To find the final velocity, we use the third equation of motion, which relates initial velocity, acceleration, and distance. The formula is 2 times acceleration times distance equals the square of the final velocity minus the square of the initial velocity. Rearrange the formula to solve for the final velocity. First, add the square of the initial velocity to 2 times acceleration times distance. Then take the square root of the result. Substitute the values. The initial velocity squared is 2.4 times 10 to the power of 7 squared, which equals 5.76 times 10 to the power of 14. 2 times acceleration times distance, 2 times 3.6 times 10 to the power of 15 multiplied by 250. This equals 1,800 times 10 to the power of 15. Add these values, 5.76 times 10 to the power of 14 plus 1,800 times 10 to the power of 15 equals 1,800.576 times 10 to the power of 15. Now take the square root. The square root of this value is approximately 13.42 times 10 to the power of 8 meters per second. So, the final velocity of the proton is about 13.42 times 10 to the power of 8 meters per second. Next, we calculate the increase in kinetic energy using the formula for change in kinetic energy. The formula is 1/2 of the mass times the difference between the square of the final velocity and the square of the initial velocity. Substitute the values. The final velocity squared is 13.42 times 10 to the power of 8 squared, which equals 1,800 times 10 to the power of 16. The initial velocity squared is 5.76 times 10 to the power of 14. The difference between these values is 1,805.184 times 10 to the power of 14 minus. Multiply this by the mass of the proton, which is 1.67 times 10 to the power of negative 27. Then divide by 2. The result is approximately 1.5 times 10 to the power of negative 9 joules. So the increase in kinetic energy is about 1.5 times 10 to the power of negative 9 joules. Here's the summary. The final velocity of the proton is about 13.42 times 10 to the power of 8 meters per second. The increase in its kinetic energy is about 1.5 times 10 to the power of negative 9 joules.